One way to create a value type with C# is to create a structure using the struct keyword. A struct definition looks just like a class definition. A struct has a name, it has an opening and a closing curly brace, and everything inside of those braces will be a member of the structure. You can even apply an access modifier like public or internal. Really, the only syntactical difference is the keyword that's being used, struct or class. Which leads to the next obvious question: when should I write a struct and when should I write a class? The general rule of thumb is that you want to write a class by default. Structs are meant for special cases when you need to write an abstraction that represents a single value, like a date time that is inside of the .NET framework that represents a single value, even though you can break a date time down into smaller constituent pieces, like the current hour or the current day or the current year. A date time does represent something that we can reason about as a single value. It's a value that represents a point in time. Other value types in the .NET framework, types like int, they obviously hold only a single value. But over the years, I've built many custom value types using struct, and I've done this to represent things like complex numbers, or a point in 2 or 3 dimensional space, or a currency amount, which consists of a monetary value and a currency symbol. All of those abstractions represent single values conceptually, and the other characteristic that those value types have in common is that they are all small. Structs do best when they contain a small amount of data, because as we'll see, value types get copied around in memory frequently. A value type like int in C# that only requires 4 bytes of data to store, and most CPUs will copy that data just using a single CPU cycle. But more on that later. Another way to create a value type in C# is to use the enum keyword. An enum creates a type that will only hold specific numerical values. An enum, which is short for enumeration, it's a good way to create named constants in your software. So here's a scenario. Let's say we're building an application to pay employees, and we already have an employee class. One attribute we need to track for each employee is how they are paid. Are they paid on an hourly basis? Are they salaried? Are they an executive? One way to represent those categories would be to give each category a number. So an hourly employee has a payroll type of 4, and a salaried employee has a payroll type of 2. The problem is, if we actually use those numbers in our source code, they become what we call magic numbers. You look at the source code and you see a 2. What does that represent? Is that employee hourly or salaried? I'm not sure. Those are the types of things that you forget about 24 hours after you write the code. And enum can turn those magical numbers into symbols. So instead of using the value 4 for an hourly employee, I can use the code payroll type dot hourly. So an enum isn't something that I have to instantiate to use. I can just use the name of the enum and then one of the members of the enum that I have defined, like .contractor, .salaried, and so forth. So in the if statement, we're looking at using an employee object. Every employee object has a field named role that is defined of type payroll type. So instead of saying .role equals 2 or .role equals 3, I can involve this enum, and the code is a little bit clearer. Defining an enum is very simple. You use the enum keyword, give the enum a name. There's an opening and a closing curly brace, just like a class. But what is inside are your symbols. Here we have contractor, salaried, executive, and hourly. By default, the first entry in an enum will carry the value 0 because behind the scenes, this enum is represented as an integer value, like 1 or 2 or 3. Inside the enum, you can explicitly assign values, as we've done here when we say contractor equals 1. What the C# compiler will do is automatically assign the next numerical value if I don't explicitly provide one. So salaried would be a 2, executive would be a 3, hourly would be a 4. And this code will just use the defaults there, but we could have explicitly overridden that and said hourly equals 128 if we wanted to. Let's take a look at this in code. In Visual Studio, let me first show you an easy way to figure out if you're working with a reference type or a value type. When I declare a variable like G1, which is of type gradebook, how do I know that's a reference type? One way to do this is to put the cursor on the gradebook symbol and use the F12 key. We've used this before. That will take me to the source code if Visual Studio has the source code available. And when I come to the source code for gradebook, I can see it's defined as a class. Therefore, this is a reference type and G1 will hold a pointer. What about integers? I can use the same trick here. I can press F12. Integer is part of the .NET framework, but what Visual Studio will do is recreate the structure of that type from metadata. So this is the metadata view. We used this earlier in the course. We can see that this is part of MS Core lib. So that's where the int type lives. Now you'll notice the actual name of this type is system.int32. It's not int. And that's just because in C#, int is a C# keyword that will give you an int32. So I could define these variables using either the C# keyword int or the type system.in32, it's all going to come out the same in the end. Those two are completely equivalent. I prefer to use the C# keyword int. But you can see here that an int, aka an int32, it is a struct, therefore an int is a value type. If I looked at the date time type in .NET, I would see it is also a struct. And this metadata view, by the way, can be very useful if you're trying to figure out what something can do for you. I can look at this int32 type and I can see that I can convert an int to a string. I can compare integer values. I can parse an integer out of a string. We will look at some of those features later in the course. For right now, I'd also like to show you how to write or use an enum that's built into the .NET framework. So let me create a new test method. This time what we're going to be experimenting with is string comparisons. So first I'll declare a variable. Let's call it name1, and it's going to point to the value Scott with an uppercase S. So is string a value type or a reference type in .NET? If I press F12, I can see clearly that string is a reference type. Don't let anyone ever tell you anything different. However, string is a little bit magical, and we'll talk about that later in this module. So string is a reference type. Name1 points to the string Scott. Let me also declare name2, and I want this to point to Scott, but without an uppercase S. And now what I'd like to do is do a string comparison that will tell me these two strings are equivalent. So I need to do a string comparison that ignores the case of the individual characters. So an uppercase S should be equivalent to a lowercase s. Let me declare another variable of type bool, so we can hold the value true or false. What is bool, by the way? Bool, also a value type, it's a struct. I'm going to say that result equals string.equals, and I want to compare name1 and name2, and there's an optional third parameter here where I can specify the type of string comparison to do. And string comparison is an enum. So if I say string comparison dot, Visual Studio will show me the various string comparisons I can do. I can compare strings and take into effect the current culture. My current culture is set up for English. I can also ask for invariant culture, so it doesn't matter whether my machine is set up for English or Spanish or French or Norwegian. And I'm going to select this option, invariant culture, ignore case. And I want to assert it is true, this result. Because if I'm ignoring the case when I compare these two strings, I should get a true out. And I now have 6 passing tests, so that has worked. Let's press F12 on string comparison and go to the metadata view. And here I can see how that enum is defined. I'm using string comparison dot invariant culture ignore case, which holds the value 3. That would actually be the value that's passed around behind the scenes. But if I try to put a 3 in here, you'll notice I do get the red underline, which indicates there is an error. So even though that underlying value is a 3, I cannot pass the integer value 3 into this method. The C# compiler wants to see something that is one of these string comparison values. That's another benefit of using strong typing and using enums instead of just magic numbers. And speaking of passing parameters to a method, another topic that we want to make sure that we're comfortable with is how these different types, these reference types or value types, how they behave when we pass them to another method.